You know what's funny? I write so neat with some big and when I switch, my handwriting's all bad. Look at this quotient. It's just perfect.
So get yourself a box of pencils.
Huh?
So get yourself a box of those pencils.
Oh, thanks, Mr. Howard. You're so nice.
I'm not giving you. This is your box.
I'm not giving you.
Really? All right. So the rule we're going to start with now is pretty much the opposite of product. Okay? Think about it this way. And you're going to use this rule again. You're going to use this rule again in about 8 or 9 concepts. And I'm not going to tell you how because I haven't learned it yet. There's something called logarithms. If you've ever read through them or read about them, logarithms, we're going to use this rule again. Okay, so just make sure it stays in the back of your mind. So when we multiply two things, what do we do to the exponents?
Combine them.
We add them or combine them. What are we doing now, though, as a rule? Subtracting them. Okay, let's show the proof of where this comes from. Very simply, if I add x to the 7th over x to the 4th, somebody please tell me, not the answer, but what's really going on here that can prove what the answer is.
Oh, you would
Not what the answer is, but what's actually going on.
Isn't that the basis? Basically, you're going to stay the same and then you're going to subtract them?
Okay, but again, I'm asking you to explain what's going on.
Yeah, 7x on top.
And how many on the bottom? Very good. Okay, so we got 4 down below and 7 up top. Hopefully that counted right. 4 are gone. Is that what's really going on there? Okay, so make sure when you do this stuff, that's what you're thinking of. Don't just memorize some rule. I mean, sure, it's good to know the rules and you eventually should memorize them, but know where they come from. So at any point in time, if you forget the rule, you can derive it. Just think of an example. Okay, that's all you want to do. So this becomes x by x by x, which is really just x cubed. Okay, x cubed. And thus, 7 minus 4 is equal to 3. Okay, think about it that way also. All right, as if you're doing a subtraction problem. 7 minus 4 is 3. Okay.
Is it always the numerator minus the denominator?
Correct. Always, always, always. Even if the numerator is smaller, which we're going to look at now to come up with our next property. So, continuing with Victoria's question, let's see what happens, though, if our numerator happens to be smaller than our denominator. So we've got an example. Let's start with, let's do this one. M to the 4th over m to the 6th. So the rule is subtract the numerator minus the denominator, right? Or the denominator from the numerator. So what's 4 minus 6, everybody? Negative 2. Okay, negative 2. But you might say, what does that negative exponent really mean, you know?
You don't have them.
Okay?
Doesn't it go from like 1 to like 10 to 0 and then up to 0? And then it
No.
goes
I see what you're saying, Jason. The series of that does go to 0. You're right. If you keep putting numbers there, it's going to get smaller, 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 smaller. It's going to look like an asymptote, like a rational function. That's what the graph looks like there. But I'm asking, like, how do I represent this differently with variables?
1 over m squared.
1 over m squared. Now, Andrew, follow-up question, prove that. You might know it because you know the rule. I know you know the rule. That's fine. But show me from this problem here, like you did earlier, where that would come from. Well, can I make this, Andrew? Yes, you do. You did it before. You did it about maybe 2.5 minutes ago, and you answered the question.
Well, I know it's wrong.
Good. Just put 4 m's up top and 6 m's down below. 4 cancel with 4, don't they? Now, when you cancel things, what's really left behind? A 1. So this becomes 1 over, and are there 2 m's there? Which is 1 over m squared. This is our next rule. Our next rule we're going to look at is exactly this statement right here, and that's where it comes from. So whenever you see a negative exponent, you make it 1 over the positive exponent. So if it was m to the negative 7, it's 1 over m to the positive 7.
So, but is this still the same if you leave it as m?
It is, but a lot of the time you deal with stuff. Okay, take this with a grain of salt. For me, m negative 2 and 1 over m squared is the exact same thing. But you got to know how to go back and forth. So in Algebra 2, what a lot of textbooks do is they require you to answer with positive exponents when they give you questions. And I'm going to try and do that just because I want you to remember what this actually is. But later on, when you study pre-calculus and calculus, it does not matter which one of these you use. Actually, in calculus, this is actually more useful. And Mr. Carter could attest to that. Remember, like the power rule and stuff? You have to have it with a negative exponent or exponent in the numerator. So it's good to know these two, because eventually you're going to see things that look like this, and you have to actually go back to this. Okay? Again, it's really more important. I know it sounds weird, but this one is actually more useful. Okay? It's a lot more used, more in calculus than pre-calculus, actually. In pre-calculus, I could still seeing it this way. But again, you should know both of them. These are interchangeable. Okay? If a problem says on the SAT, you know, what is the simplest form, and you get m to the negative 2 as your answer, but it's not a choice, look for that as one of the choices then. Remember how we've been talking about multiple choices for SAT? That's what you want to be doing here. So think about what that can be rewritten as. So whenever you have a negative, think about it as a positive 1 over, because that might be the actual choice in the problem. All right, let's do another example now. Let's take a look at x to the third, and I'll explain the rule. You can write down the rule if you'd like to. The second part of the rule is a bit of a variation, but the first part is what we just said. X to the third y squared over x to the seventh y z to the negative third. So if you want to write down the rule, go ahead. All right, before we start the problem, let's take a look over here at a quick note. If I said I have 1 over n to the negative 4, 1 over n to the negative 4, how can I rewrite this? And I want you to think about it. You might not know right away. And why can I rewrite it that way? What evidence can you show me? So there's another way to rewrite this with a positive exponent. I'll give you that much. With positive exponents. How can I write it and why? And there's two parts to the question, right? How can I rewrite it and why? I would recommend just starting by writing it out. What is n to the negative 4? Isn't it really 1 over n to the 4? Can't you write this as 1 over n to the 4? So you could write this as 1 over n to the 4 from our last rule. Isn't that what that says? When you see a negative, you write it as 1 over the positive. Again, I see a negative. Whenever you have a negative exponent, you can rewrite it as 1 over the same thing but a positive. So I'm simply rewriting my denominator as a fraction now. So now I have a fractional denominator. That's all I've changed. But we have to think back. What does dividing by a fraction really mean? Multiplying a reciprocal. Well, we're taking 1 and we're dividing it by quantity 1 over n to the 4th. That's what we're doing here. So I'm really saying 1 divided by 1 over n to the 4th. That's what's going on there. Well, when you divide by this, we multiply by the reciprocal. So we write it like this now. But what's 1 really over? Isn't it over 1? So we end up getting n to the 4th over 1, or simply n to the 4th. So what this tells me is that not only can I start with a negative exponent and make it 1 over the positive, if I have 1 over a negative, I can just move it up to the top and make it a positive. So here's what I want you to write down as a note. When there's a negative exponent, switch its location, and I'll go further with that, switch its location and make it positive. Again, when there's a negative exponent, switch its location and make it positive. That'll be our general rule. And that's what you see over here right now. This rule right here is what's really important. Okay, and we'll explain again because these would both become negative, so I'm switching their locations and making it positive. So let's go on to our actual example now. Do we see any negative exponents to start?
Yes.
Tell me.
The z negative.
The z negative 3, right? So what can I do with it right away?
Put it in the
And make it positive. Okay. Now, if you didn't believe me, if you still don't believe me about this, here's what you think about. If I had z to the 0 up here, because any number to the 0 is 1. Remember, any number to the 0 is 1. So I could just put z to the 0 in there with no problem at all, because it's just 1. If I have z to the 0, wouldn't I have to subtract these exponents because I'm dividing? And what's 0 minus negative 3? It's, what is it? Positive 3. Be careful. 0 minus negative. Minus negative is a double negative. So that would actually become positive 3, which is the same as moving it up to the numerator. Okay, again, you don't have to remember to move it up, but you can always put a z to the 0 over there. But as we know, we can just move it up to the top. So I'm going to move this up to the top as z cubed. Next, I've got x to the 3rd over x to the 7th. What do you got here for me? Look at the x to the 3rd and the x to the 7th. What do those simplify to be?
1
Okay. What is it? Be careful. Top
Negative
mouse.
4.
Negative 4. Okay. Or, Vanessa?
1 over, what is it, x to the 4.
To the positive 4 there. Again, take a look. Aren't there 3 x's up top? How many are down below? So 3 of them cancel. How many are left down below? No, how many are left down below? 4. So either you can remember to just do 3 minus 7, and you'll get negative 4, and then you think of moving it to the denominator, making it positive 4. Or you can just look at it and say to yourself, this is what's really going on. This is what's really going on. And clearly, these 3 cancel with these 3, leaving these 4 behind in the denominator. That's what you can always think about. Or you can memorize 3 minus 7 is negative 4. You would end up getting x to the negative 4. But then you would make it positive and move it down to the denominator. So either way, it works. What about the next part? Y squared over y. Y where? In the top or bottom? In the top. Let's go over that. This is really y squared. So this is really y times y. And this is just y. One of these y's cancels with one of these y's. The y that's left over goes up top. And seriously, guys, I always visualize in my head how many of each variable I have. That's what I remember. So you can remember to subtract the exponents when you have division. That's fine. But all the time, I'm always thinking about this. Because I don't want to deal with negative exponents. And if I can avoid that, it makes it a lot easier. So by thinking of it this way, when I cancel the 3 x's on the top and the 3 x's down below, I end up with just 4 x's down below left over. Okay, again, when I cancel this and this, I end up with these 4 left down below. And it avoids having to work with negative exponents. Okay, but you have to know that a negative exponent just means a positive exponent either in the top or the bottom or the switch location. So this would be my actual answer right here. yz cubed over x to the 4th. Okay? We clear on this so far? Again, this has got to be down pat, this stuff. This is the easy version. This is a much easier version than what we're going to do. Okay, the next concept, we're going to be looking at exponents that are fractional. So what if this is like, instead of y squared, what if it's y to the 2/3 or y to the 1/2? So we have to be able to manipulate these in a way so that we don't make mistakes with simple math along the way. So the rules are very, very important. What can you do, honestly? What can you do as a study guide for something like this? What's the easiest thing to do? Problems, very good, obviously. Besides problems, there's homework and everything, but I mean as a study guide. A chart if you like, okay, what else? An organized chart with all the rules and all the property names. Maybe the name, all the rules, and then an example of each. That'd be a good chart to make. What else? What are the most basic study guides that the teachers always do? Flashcards. On one side you put the name of the rule, product rule, and the actual rule. Okay? Flip it over, you have an example of it. That's it. Just think about it that way. Okay? Again, please make sure you have study guides. So if it takes, making a chart, rewriting your notes, whatever it takes, you have to think about doing that. Especially when you go to college, this kind of stuff helps. It really does. Because you know what? We cover all this material in a full year. The same amount of material we're covering in this entire year is covered in pretty much half a year or a semester when you're in college. And not only that, you don't meet 5 days a week from that. Like we meet, here we meet 4 days a week actually. So this is closer to college than anything else. That's one thing about high school here that really does prepare you, I think, a little bit better than other high schools. It's closer to college. Because high school normally is 5 days a week, right? Then you go to college and it's 3 days a week. And they're 3 days a week and they're only 50-minute classes. We have 4 days a week and they're 55-minute classes. So you guys have an extra day of class. But when you take calculus, you usually have a 4th day of class. It's one of the exceptions. Calculus level 1, calculus level 2, calculus level 3, they're 4 days a week, and they're 4 credit classes. Whereas most college classes like philosophy, theology, physics is a 4-level class also. Most of your basic humanities and social studies, you only need 3 days a week for 50 minutes a day. But for math and science, because it's a little more complex, you have what's called a recitation day. Recitation simply means you have a 4th day. So for example, Monday, Wednesday, Friday, those 3 days are your normal lecture periods. And then on Thursday, it's a problem set or some sort of a quiz. Some teachers make it into a quiz. They'll actually have a quiz for you and stuff. Others might do like an oral quiz, where students come up to the board and actually go over problems. And that's your quiz grade for that day. So you have to go up and actually go through a problem. And some just do problem sets. I had a teacher that did exactly that. She would just do really complicated problems every Thursday. And it pretty much just took the last 3 lessons from the previous Wednesday, Monday, and the previous Friday, and then lumped those 3 together and just went over questions on those. Okay, so just keep that in mind when you're doing this stuff. You have to come up with your study guides. There is a lot of material crammed into a very short amount of time. Okay, a very short amount of time.
I think you can take all your classes. I heard you can take more than just
You can take, so another way to take your classes, instead of, so for the general class, instead of taking 3 days a week, 50 minutes a day, you can do 2 days a week, an hour and 15 minutes a day. Can somebody do attendance for me? I'm talking here.
Brandon's gone.
So you can do, instead of 3 days a week, just label the time period one minute. You can do 2 days a week with an hour and 15 minutes per class, actually. That's another way to do it. A third way to do it is to do it 1 day a week, which is like a night class usually. Usually it's night class. Some schools have them during the day also. And it's 1 day a week, and it's 2 hours and 30 minutes. It's the same amount of time in the end. 50 minutes, 50 minutes, 50 minutes is still 2 hours and 30 minutes. An hour and 15, an hour and 15 is 2 hours and 30 minutes. In the end, for 3 credits, you do 2 hours and 30 minutes, traditionally. Some schools could change that, but I've rarely seen that ever happen.
Wow.
And if you have a 2 hour and 30 minute class, it's usually on the schedule for 3 hours. And the teacher usually gives you breaks, because 2 hours and 30 minutes is far too long for anyone to keep their attention. I would never want to do that. After like an hour, I have to like get up and leave. You guys realize that's why periods are what they are, right? The average attention span. I mean, the average real attention span is about 30 to 40 minutes. So when we have like the quiz at the beginning of a period, and that's what, 10 minutes pretty much, about between quizzes and getting started, we only have left about 45 minutes. And that's one of the major reasons I actually do those quizzes, believe it or not. I know you guys don't like ever think about this stuff, but as a teacher, you don't want to be lecturing for more than like 40, 45 minutes ever. So if you walk in and I start and we go right to the end from every little point, like today, I'm kind of breaking it up right now at least, but it's not, you know, as much as I'm getting up and moving around.
I've been moving like that last year.
For the geometry, I just never did that program. I'm doing it in all my classes now, though. Well, actually, I'm not doing the physics yet. I'm doing the calculus and doing this class. Calculus, we start with a problem usually. We have quizzes. It all depends. It all depends. As you get older, guys, though, teachers do expect more of you. So, like from the seniors, I expect that they should be fine from beginning to end. That's 55 minutes. That's what a college course is going to be, 50 minutes. So I'm just saying that they should be able to do 55. For now, though, I'm giving that 10 minutes in the beginning. It also does help people get settled in sometimes and stuff. So I understand that. Anyway, let's continue. Let's look at the next rule. All right. So looking at the power of a quotient, not quotient of a power, or not quotient of power. Thank you, Vince.
Wake up.
First name and everything. First name and everything's on there. All right. So what is this rule pretty much saying, guys? Anybody?
Oh, you distribute it.
Yeah, I mean, like, remember yesterday we said we're not going to call it distribute, but that's pretty much what we're doing, yeah. We're just associating the C with both terms. We're really distributing a power, okay? So let's take a look at one quick example. What if we have, and now I'm gonna have distributing a power with the negative exponents.
X over Y is a negative.
x cubed y squared over x squared y to the negative 4 all to the negative 3. All to the negative 3. Now, here's my thought, or let me get your thought first before I get into this. What's the first action you would take here? Okay. Parentheses? Okay, what do you mean? Okay, so work inside the parentheses first. That works for me. That works for me. That's absolutely working. What's another way to do it? We'll take that route. I agree. So distribute this first, or do this first? Okay, or do this first. You could distribute this first also. You really could. That's what I'm trying to say here. Doesn't matter. But if you distribute the 3, you're multiplying the 3 by each of these, right? Aren't you really raising a power to a power? So this will become negative 9, negative 6, and those are higher powers. Let's just simplify first, and then we'll worry about that negative 3 after. So the negative 4 here, what does it really mean? Yeah, 1 over y to the 4. So what should I just do with it? Just bring it up. Remember the rule, guys. Forget about 1 over. Just remember, switch the spot. So take this, switch its spot. Just move it on up. Okay. So I got y squared and y to the 4th now. Because doesn't this move up as y to the positive 4?
Y6.
That's what happens. So y to the 6th. Okay. Again, when you take a negative exponent, you move its spot and make it positive. So y to the 2nd times y to the 4th, you add the exponents. 2 and 4 gives me that 6. Again, don't forget I still have this negative 3 out here. Next. Next.
Isn't it x?
Why is it x?
X on top of more than 5.
Good. Do I need the 1 down below, really?
Not really.
I don't. I have a fraction line. I'm going to leave it for now, but I don't really need it. Okay? So again, this is really x up top, and down below this is simply x. What happens? 2 cancel with 2 of them. We're left with just x up top. All right, awesome. Now I've got this negative 3, right? So what should I do with the negative 3? All right, so what's it going to do to my exponents, though? It's going to make them what? So what am I going to have to do eventually if they're both going to be negative? Move them down and make them what? We're going to have to, these are going to become, this will become negative 3, because there's really a 1 there right now. This will become negative 18. So I'm going to have y to the x to the negative 3, sorry, y to the negative 18. So they're both going to move down below, right?
Yeah.
So shouldn't I just move them down below now?
Yeah.
So I can do this, and I can think about it this way. I can write it out again like this, and just make the 3 positive now, because that's what's going to happen anyway. Think about it logically. This will become x to the negative 3, y to the negative 18, which will then become 1 over x cubed y to the 18. That's what we're going to end up having here, if we do it in this direction, if we distribute the negative 3. But if I just write it like this, now I'm going to see I get the exact same answer still. It doesn't matter which way you want to do it. I'm just showing you guys different methods. But take a look at your answers. They're right now. Again, so you have one method. You could have distributed the negative 3, and then you take this path up here, and you get this answer. But instead of distributing the negative 3, if you make it 1 over the positive, and you make this a positive outside, then you go to yourself, move it on over here, distributing the 3, you get x cubed and y to the 18, and then down here. Okay? Again, the key here is to remember your rules, but not individually, but as a whole. Because these kind of problems, you don't see one rule. An SAT problem is not going to say, what's x squared times x cubed? Please tell me. Like, that's just, I mean, it's not. That's far too easy. Even for easy level problems, that is far too easy. A problem that we just did now, I would say would be medium level. Medium. Because of the negative exponents, because of the negative exponent on the outside, because of the power rule, because you're going to add these two, because of the quotient rule, because you're going to distribute that, because of the power to a power rule, there are 5 rules here. Okay, all in one. That's why this would be like a medium problem. Okay, a difficult problem would not be something with just this. This kind of a problem would never be considered difficult. A simple problem or an easy problem would be something like this. maybe with a 6 up top. Something like that. Okay? That would be like an easy level problem. Because there's not too much to work with. There's not much on distributing exponents. There's no negative exponent right away. You can cancel these. 6 over 3 is just 2. These x squareds cancel. Okay, that would be like an easy level problem, whereas the one we just did with median.
So if it takes more work, it's a harder level.
If it takes more thought, because what are you doing here? You are combining 5 different concepts in your head, or 5 different ideas. Negative exponents, quotients, powers, power to a power. 4, not 5 rules, 4 rules. But there was a 5th I was thinking of. Okay? Had maybe this turned out to be x to the 0, and your order has 1, then there'd be like a 5th rule there. But again, you're just putting a lot of stuff together. Okay?
Wait, real quick question. So when you're distributing at negative 3, I think the fraction of 1 stays the same. You won't get the which is 1.
Well, okay, that's a good question, John. I didn't even. You're absolutely right. We should analyze that. Because that's going to come up if it's not a 1. Very good point, John. So if we were to distribute the negative 3, this is now 1 to the negative 3. Right? He's absolutely right. And I didn't put it there. Because what's any number to a negative again? If it's negative, what do I do?
Like any number to negative?
Anything to a negative, what do I write it as? If I had, take a look here, 1 to the negative 3, how can I rewrite that? 1 over 1 to the 3, right? I rewrite it as a positive exponent in the denominator. What's 1 to the 3rd, though?
1.
And what's 1 over 1?
1.
Whenever 1 is raised to any power, what's the answer going to be?
1.
1. Okay? Again, whenever 1 is raised to any power, you're going to get 1 as an answer. Okay, the only time you might see a difference is if you think about the square root of 1. Because it's plus or minus 1. And soon you're going to see how the square root of 1 can be written as a power. So I don't want to mislead you there. But whenever you look at 1, it's going to be 1 as your answer there. Okay? You could write it as negative 1 sometimes. But that's when you have square roots. When we're not like that. And it would not work that way. So hypothetically speaking, had this been a 2 here, okay, let's say this word 2, put a 2 there, this becomes 1 over 2 to the 3rd. What's 2 to the 3rd? 8. So this denominator would become 1 over 8. Or I would just bring it up top as positive 8. Okay? And we'll do an example of that now. We'll take a look at an example of that. All right, let's go through 3 examples here. Okay, we're going to simplify these. Now, I did not put in the instructions here with only positive exponents. We're going to do that, and it says in your homework. So I need to add that in my notes. Yes. If there's nothing there and there's just parentheses, always multiply. Is this homework? No, this is some work we're going to do together. Some more complicated problems. All right, who wants to do the first one for us? And don't just do it, Derek. You know that. Just step it out, please.
See, I didn't even notice the negative. I was going to first. Right. Let it go. I want to say 6x4 y 3. I don't know what to do with that negative 3.
All right, so I got a question for you, Derek. Where'd the x to the 4th come from?
The x to the 4th.
Mm-hmm.
I mean, oh, no.
I see what you're doing. Derek's distributing this 2 on the left side and then combining over here, but he's not associating the negative 3.
That's what I'm
Can't
saying.
ignore that.
Yeah, that's what I'm saying.
Can't ignore that.
So what would you do with the negative 3?
What does the negative exponent mean again?
Oh,
One
so
over this.
1
over the
yeah.
positive. So I would write this as 1 over this entire thing with a positive exponent.
Magic.
So
Which part?
How do you know? He said.
did you put that 1 right there? I feel lost. I feel lost right now. And
Okay,
then-
let's stop.
Yeah.
Because I think we're a little bit confused.
Erase it with your finger now.
What should Derek be doing? Somebody help me out here.
Well, is it what you did over already in M fraction?
Yeah, it's not 1 over 1 over. It's just 1 over this thing to a positive. So like that, but now rewrite this to the third. Okay. In parentheses, please.
The whole thing?
Well, what needs a parentheses? Think about it. Thank you.
Alright.
Okay.
You just tell me put your right there.
That's fine as long. Again, Derek, if you put parentheses there, then your 3 should be down here. If you put parentheses the whole thing, then 3 is up top. You can ignore the 1 up top to the third, because what's 1 to the third going to be? It's still going to be 1. Okay?
And then get the... Then that's when you stop.
Okay, Derek, slow down, man. Why are you putting that in the denominator? What does it look like in the denominator? It looks like if
it
me.
wasn't part, no. I was trying to put it as multiply.
Okay, then you should probably put it like even level with the actual page, right? You see what I'm talking about, guys, though? When I read your quizzes, you got to be writing this way. It takes me sometimes far too long to read them because I don't even know what's actually written there. I'm confused as to see what's even on the paper. Okay, so please write them in a fashion so I can actually understand. Good.
Who's sleeping?
All right. Good starting point. Somebody want to come up and finish?
It's you?
Finish it.
It's you?
We're good so
I
far.
don't want to finish it, but for
Problem, my
the
beautiful
left side,
city.
wouldn't that be 4x squared minus 2?
All right, so start. So Trayvon is saying let's start by distributing this 2 to everything. So 2 squared is just 4, absolutely.
4x squared.
Then we're going to have
4x to the second power.
x to the second, good.
Y to the fourth power.
And then z to the... Again, take this 2, even though I don't know if you can tell. Let me just, so you can see. Take this 2 and distribute it to everything in this entire term. Okay? X to the 1 is really here. Z to the 1. Remember, when you raise a power to a power, you multiply those powers. So 1 times 2 gives me x squared. 2 times 2 gives me y to the 4th. 1 here times this 2 gives me z squared. Right? The bottom. Jason, what do I got from the bottom over here now? From this term. What am I going to write down here? Come on. You can do this. Distribute this 3, Jason, to all these.
Does it also go to the north?
It does go to the 3 also, yeah.
So that'd be 9x.
Third power, not second power. It's 3 to the third power.
Oh.
3 times 3 times 3.
27 x to the 6th power.
Good?
Y to the 3rd power.
Good?
And z to the 9th power.
Very good. Again, what did he do? He did 3 to the third, which is 3 times 3 times 3, and then he raised all of his powers to the next power by multiplying those powers. Again, you take this 2 here times this 3 that's outside to get the 6. You take this 1 that's really here times 3 to get 3. You take the 3 that's here times the 3 to get the 9 there. And now at this point, try to simplify. Okay? Well done. Let's simplify this. 4 and 27, does that simplify?
Nope.
No, so just leave it. I got 2 x's up top, I got 6 down below.
If you have 1 and 1 over.
Put it x over 4.
Thank you. So let's just say 4 down below. All right. Now, I've got 4 y's up top and 3 down below. 1 up top. I've got 2 up top and 9 down below. 7 down below or 7 in the bottom. Very good. Okay? Again, ignore the negative exponent part right now. Because if you subtract these, you're going to end up with all the negative exponents. I'm showing you much quicker ways to do this stuff. You got to know the negative exponent rule, though, because it might come up on your SAT. They like to put stuff on there with negative exponents. So you have to know what to do with it to manipulate the problem. So that's our final answer for the first one. All right, can you try the second one on your own, please? Try the second one on your own, please. If you finish, I'll come check it if you would like. Just raise your hand, I'll come over.
Is that a 3 next to the z?
Is that a 3? Yes, so it's -3, a to the -2, b to the third, that whole quantity squared, that quantity divided by a squared b, that whole quantity to the -1.
So I don't want to feel negative. So the stress is down below. So the line is down, the line is down below, meaning 1 line top. So 2, 0 top, 9 down below. 2 of these cancel, 2 of these are second. If you just use your basic rules when you've got these information, subtract exponents from 2 minus 6. So instead of putting x to the negative 4 at top, x squared x to the top. It makes it a little easier, obviously. No, that's the thing. I have to go straight first before you
Why is that? What happened? What happened?
Absolutely. Is there happiness? Yes.
That's -2 and that's +2 down there. Cubed, that's a 0 out there. That's a 3, that's a 2. I should just make these bigger. Does that work better?
What's the -1? Which one? A or something? It's A. So then A is just A. As long as there's parentheses around 9A, that whole thing is there. 9A then, but I don't see parentheses there. Okay, why don't you distribute it?
Guys, start by distributing if you're stuck here. If you're stuck on number 2, distribute to start, please, and then start moving after that. I'll be right down the line.
Why is that negative? Yeah, it was -3 squared. -3 squared is positive, right? Here. Number 2.
Because I'm sure that'll be a choice there, Andrew.
A looks from 2 times 3 times 2 gives you 6.
So no, it was like 2
And 1
times.
gives you 7. It should be negative.
Exponent, it's exponent, so it'd be negative.
Cube. I mean squared. So it'd be -2 times 9. You have to have 5 or 9. It was in the bottom. That's negative. It's gotta go on top.
2 goes over here.
What would you do, John?
Shut up, Jason. And it'd be -3 times -3, which is +9. It's just exponent. It's gonna be a simplified.
Not -3.
So you just leave it. It's square on the outside?
No, you simplify.
So like that negative. So your answer would be 9A. -4.
B to the third, and it'll be to the 6th.
2 times -2.
Dude, why is that negative? You have what, a to the negative 4 and a negative 2? I would switch them around a negative 2 and make it positive 6.
So you get negative 2.
You get 2 8 over down below, but not negative 2. Yeah, you're right. Yes. Oh my God.
Yeah, you just go negative 3 to negative 2.
Yeah, I just read that, so I thought it was 2.
You do negative 3.
Oh no, the bottom one would be 1 over
You distribute.
A squared, but that's negative squared, and you just multiply that times. So after that point, you're just adding. So you're not really 1 over A squared.
It's right there.
Yeah, no, A squared A to the 1.
What problem are you doing? There's a negative 3 you over. But you have to distribute it.
Number 2.
At the bottom? Yeah, it's there.
Alright, so,
You can explain that.
some of you picked up on the way to do it. There are certain ways that work easier than others. There's more than one way to do this problem, though. I'm going to give you the easiest way. I would start by distributing the power. Okay, distribute the power, whatever it may be. So negative 3 squared is just 9. That's what you have to start by remembering, because you're squaring a negative number, positive 9. Then, a to the negative 2 to the second. You take the negative 2 times the 2, you get a to the negative 4. B to the third to the second becomes b to the sixth. That's what I would start with. Now do the same to the bottom. We have a 2 times a negative 1, giving me a to the negative 2. B times negative 1, giving me b to the negative 1. Again, start by distributing your power. Not until you actually have negative exponents. Guys, if you have the negative on the outside, you can always start by distributing it. In this case, it makes it a lot easier. Just watch and you'll see what I'm saying. Now you have negatives, right? Make them positives and just move them around. So on the next line, rewrite everything the same way. But wherever there was a negative, move it to a different spot and make it positive. So the 9 stays up top. A to the negative 4 becomes a to the 4 down below now. I take it from the top up here, and I move it down below as a positive. I take the b to the 6th, and I leave it up top. I take the a to the negative 2 that was in the bottom and move it to the top as a to the positive 2. B to the negative 1 that was in the bottom, I move it to the top as b to the positive 1. Then I'll just simplify. And that's what I'm going to do. Now let's simplify. This becomes b to the 9 remains up top. What happens to the a? I got 4 down below and 2 up top. 2 in the bottom. You could say a to the negative 2, Jason, but I would just put 2 of them down below. Okay, it's the same thing really. You could put a to the negative 2 up top. But here, think about these 2 canceling with 2 of these, leaving 2 behind. Right? And this is your final answer here. So these kind of problems, there's not just one cookie-cut way to get your solution. You can do it several ways. My recommendation here would be to do that. You cannot, and I'll tell you this right now, you cannot start canceling stuff. That's one thing you cannot do. So you can't try and cancel, one of these b's with this b and write this as b squared. It does not work. Okay, again, because this is really squared. You got to do that first. So you are kind of using PEMDAS there. Okay, you are kind of using PEMDAS there. You said it. Well, this is not, the numerator is not going to be negative. Only one portion of the numerator will be negative. So that wouldn't help you too much. You could take this a squared b, since it's to the negative 1, and technically you could start the problem by getting rid of it and putting a squared b up top. Because a negative 1 really means move it up to the top with a positive 1 out here. So you could have done that and then, distribute it here, and solve the problem that way. That's one way you could have done it. But my recommendation, again, when you have powers, start by distributing the power. Start by distributing the power. Okay? Let's take a look at number 3. Let's take a look at number 3 now. All right. For number 3 here, what's the first thing you want to notice? The 0. What's anything to the 0? So that whole numerator is just? Very good. Because all that stuff is to the 0. So whatever quantity this is, if this is 10, if it's 20, if it's 30, if it's 40, it does not matter. It's still going to be 1 because it's raised to the 0th power. And now, just work out your denominator. We got to do a little bit of math here. Negative 2 to the 3rd, negative 8. Or again, you're doing negative 2 times negative 2 is positive 4 times another negative 2 is back to negative 8. If you need to write it out so that you're remembering this, this becomes 4 times negative 2, which is really negative 8. And you should know this already. When you cube a negative, it remains negative. When you square a negative, it becomes positive. If you raise a negative to a 5th power, it goes back to negative. If you raise a negative to the 4th power, it's back to positive. It's even odds there. So here you end up with a negative 8. Awesome. What about the A? And then B to the? So I should rewrite that. What's the only thing I should really change?
Negative 6.
Okay, and do I need the 1 up top still?
Nope.
Because now I got the 8 to the 6th. I got B to the 6th. I got an 8. And you know what I'm going to do? Just to mess with you guys a little bit? Let's put the negative out in front. Oops. Let's put the negative out in front. I want to use different colors so you can see it.
Does it matter either?
No, that's what I'm trying to show you. If I have a negative down below, right, it's still negative, isn't it? If I have a negative up top, it's still negative. If I have a negative in the front, it's still negative. When is it not negative? If I have a negative where? In both of them. Because a negative divided by negative is a positive. So remember, the negative can be down below, it could be up top, it could be in front. It does not matter. But if it's in both spots, it doesn't work. Okay? All right, we got about 5 minutes left. If you did not ask for homework yesterday when I asked, please raise your hand. If you do not have a homework, raise your hand. It is Tuesday, it is indeed. If you have a homework ready, please get that started on it. You got 5 minutes. You get a few of these done. Guys, you want to be doing tonight at the minimum, at least half this worksheet. So at least the first 8. Okay, you're front and back. There are 16 problems on here. At the minimum, you should be doing at least 8 of them. To me, I think it would be really good practice to do all 16. And if you really get used to it, and for some of you that are really good with this stuff, it might take you 20 minutes. If you have a little trouble, it might take you 30, 40 minutes. Okay? We're going to pick up with more stuff like this tomorrow, but we're going to start looking at exponents that are fractions. Okay? It's going to be 49. Remember we skipped 47? Okay, 49. Tomorrow, your quiz on this, multiple choice, remember, first quiz tomorrow, I guarantee it will be multiple choice, and you'll have to reduce an expression like this. And all those common mistakes that people are making, those will be the choices. Okay, you got to be very, very cognizant of what you're doing.
But you're adding. It's a power to a power. What you do with power to a power? Good. Where? And then what do you do then? And then next to the third, next to the 12. And then next to the... Turn this to 1 over 15. There. You want to do it in your head like that, it's fine. Okay? But make sure you really understand. Some of you might be able to do these in your head. You might be able to do a few of them in your head. If you can, that's fine on the test. Try and show some work for your homework, though. You should probably stop recording, right?